Welcome back, friends. So, in this last lecture in this series, we will be now looking at one specific multimodal facility, which is the park and ride facility, where we are going to expose you to or give you the idea about what is the planning process that goes into establishing a park and ride, why is park and ride a necessary station or a necessary element in an multimodal urban transportation system, and give you a mathematical formulation or a mathematical way to determine where to locate your park and ride station. So, there are different types of park and rides. We gave you a little bit of an example in the previous lecture. A park and ride could be a local park and ride that is serving as a collector, for example, transit terminals, bus, metro, etc. So, we told you that even a metro station can be considered as a park and ride station, because you can park your vehicle at that metro station and then ride the metro, right, or ride the BRT. So, even if you come by bicycle, you can park your bicycle there. If you come by a two-wheeler, you can park your two-wheeler there. So, that is a basic type of a park and ride facility, or a park and ride station, park and ride station. Yes. Then it could be a remote park and ride facility, which is intercepting automobile trips near origin with express bus rail service to the CBD and the activity centers. So, what happens is maybe you have a suburban area and there is a lot of demand for people going to the central business district in the morning, because majority of them maybe work in that central business district from this suburban area. However, the suburban area is a little bit large, and you cannot have your express bus or rail service go into all parts of that suburban area, right. So, if you have such a situation, what you allow is that you allow for all of these people from the suburban area to kind of collect themselves at a location that is closer to this express rail or express bus. All of them come, drive there to that place, or get dropped off at that location, at that remote location, and from there they take on the express bus or the express rail. So, that is kind of a remote concept, or a remote park and ride facility, and we will show you some pictorially how they are different. And then there is a peripheral kind of a park and ride facility that is on the edge of the CBD or activity centers, usually within 2.5 that is a 2.5 kilometer of the destination. That is more of a number. So, what happens here is you have park and ride facilities at the edge of the CBD itself. So, maybe the CBD is such an area where people have, or the authorities have prohibited the use of single occupancy vehicles or private vehicles, right. So, many of the CBD areas around the world, because they are so heavily polluted, so some of the strategies are to avoid single occupancy vehicles to entering into the CBD, and encourage the use of only sustainable modes within the CBD. That includes public transportation, bicycling and walking. So, what they do is, in the periphery of the CBD, they will allow people to drive till the periphery, have a lot of park and ride lots there. So, they park their vehicles there, and then they ride either a bicycle sharing system, or a metro, or a local public transit, or whatever it is. So, these kind of park and ride stations are at the periphery of the CBD area. So, these basically are three large broad categories of park and ride facilities that we are talking about. So, what are the advantages of park and ride facilities? The primary intent or advantage of the park and ride facility is to increase transit travel. So, what happens is, public transit, like usually runs on fixed routes, right. They cannot come to your doorstep, right. So, if they cannot come to your doorstep, so one of the disadvantages is, if your origin or your destination is away from this fixed route, then usually what happens is people are discouraged from using the public transport system. They feel that, well, just to access the public transport station I have to go 2 kilometers or I have to go 3 kilometers, whereas my total journey length in itself is maybe 6 kilometers or 7 kilometers. So, should I take a chance and go 1/3 of my trip length and then change a mode and then get to my destination, or should I just pick up my vehicle and go to my destination? So, that is the choice thought process that goes along when you are talking about accessing public transportation system. So, since it is on fixed routes or on fixed sometimes even fixed right of way like such as rail. So, in order to encourage or attract people to using that, these park and ride facilities were first thought of. So, what they were considered was that, okay, since we cannot come to you, so since the public transportation cannot come to you, what we can do is we can provide this kind of remote facilities or this kind of intermediary facilities where you come to that place and from there onwards we will provide you our services. So, that was kind of the idea that we, by providing park and ride services, almost they were giving you the impression that public transport is coming closer to your house than where it was originally because of its fixed route, right. So, that is the thought process that went into these designing or providing these park and ride facilities. They could reduce urban highway traffic congestion. So, if they are likely to increase public transit mode share, they will reduce definitely the use of private vehicles, and hence they would reduce traffic congestion. Automobile park and ride lots are the modest reduction. They have been seen to have only modest reductions in local traffic because if you like I was saying in the previous lecture, if you allow for parking of cars at such park and ride locations, so people would then access these locations using their cars rather than using any sustainable modes. So, automobile park and rides have not been so successful in reducing local traffic. However, bicycle park and ride lots have greater economic and environmental benefits. So, public bicycle sharing system, if it is available in your city, or if you are looking to make it to bring it to your city, then you should have such public bicycle sharing systems share station space with your metro or your larger BRTS, whichever you have in your city. So, that will definitely give you a lot of economic and environmental benefits. Okay. Financial impacts, we told you that shopping centers adjacent to park and ride facilities tend to benefit the additional shopping. That is why the entire TOD was being looked after, is being still envisioned in India, is to have some provide some financial benefits for designing such park and ride lots or park and ride transfer facilities, because otherwise if it is just an open lot where vehicles are parked, then it is not the most efficient or economically viable means of space utilization, right. You have to utilize the space in multiple fashion in today's environment. You cannot have a single use for one type of facility, that becomes unviable during the course of the time. So, what park and ride planning process adopted was something called the systems planning process. So, the systems planning process, there are twofold. One is the system level, one is the site level. So, you have to look at a park and ride facility from the point of view of the urban transport system as a whole, or all the and connect all the park and ride lots appropriately, and then you have to have some site specific planning for each of the park and ride lots as well. For example, transit agencies must be able to provide services to each individual park and ride lot if the lot is to serve as a transfer point between vehicles and transit modes. So it cannot be that these park and ride lots, 2 of the park and ride lots are well connected to the transit system, whereas 3 are not well connected. Then the system as a whole does not function very properly. Park and ride facilities will fail in the purpose if planned without the participation and commitment of the local transit agency. You have to definitely partner with your transit agency, because this is meant, these facilities are meant to enhance the transit usage. So systems planning process is the chosen process. Planners and engineers during the system planning process is in large part one of facilitator and information gatherer. So you have to have lot of information that has to be exchanged between this transit agent, the transit operator and the operator of the park and ride lots, right. If you do not have a lot of information that is exchanged, then these things will start to fail, because now if I as a potential user of the transit system do not know, for example, if this park and ride lot is full, right. There may be a scenario in the morning when there is a morning rush hour, a park and ride lot gets full. Now, if that information is not available to me prior, then I go to this park and ride lot and find that, well, it is full, and then I am already in my car. So, what that will encourage me to do is just take my car and drive to my destination and not make that trip on transit. So, that is a loss of one transit trip. So, similarly, if 100 people lose and have no information about the parking availability at that lot, then they would again start driving. So, this is a very important aspect in the case of park and ride lots and park and ride facilities, that information has to be gathered and disseminated to the users. Of course, participation of agencies, communities and concerned citizens must be the primary decision makers. We have already looked at this. Several stakeholders have to be always consulted prior to planning or setting up any kind of a system. So, the primary activities in this, and this is a list of all the activities, and you would see that public involvement is there in each of these steps. So, all of these activities are pretty generic in nature, but they have to be followed needless so as to develop these park and ride at a system level. Otherwise, you would see that they are working good at individual level, but they are not working very well at a system level, right. So, you have to have first an inventory, of course, then you have to have a demand analysis, right. You have to know how many people actually would want to park at that station and take the metro. If you do not know the demand, then you would not be able to provide for so many parking spaces, and then that situation would arise that we just spoke about, where people would come and get no parking spot, and then they would just have to drive away in their vehicles. Obviously, you have to set up some goals. So, the goals could be that transit ridership would increase by 5% if I have a good network of park and ride lots, right. That may be the goal, because remember the intent of park and ride lots is to increase the ridership of public transport system. So, if you work with a goal in mind that today the public transportation ridership in my city is 10%. 10% of the city's people use public transportation, which is very low, and we want to increase that. So, in order to increase that, we want to now put in our park and ride lots. So, now the goal of these park and ride lot system would be to increase the ridership by 2% maybe. So, if you have that goal in mind, then you can work towards achieving that goal. So, there has to be always goals, objectives that have to be set. Otherwise, you are just working aimlessly almost. So, you do not have any goal or aim towards working. So, set up your goals and objectives, develop measures that will perform that will always measure whether you are working towards your objective or goal or not. These are very important, and these measures have to be monitored at specific times, specific time intervals, not only at the end of the year or when somebody higher up has asked for an answer, only then you kind of cobble together what has been happening. It's always a good practice to have continuous monitoring using these measures of how your system is working. Develop network plan and evaluate alternatives. Maybe there has to be plan B if your current network of park and ride lots are not working. What is the alternative? You have to maybe tweak the design of the park and ride lot. Maybe you have to reduce the parking cost of that lot. Maybe you have to subsidize the ticket cost on the transit line for people who are using the park and ride lots. So there are many strategies that you can develop in order to attract more transit ridership and have at least one or two alternatives in place. Environment level, policy level environmental and community review, of course, has to happen from time to time, whether sometimes people queuing up at these park and ride lots to enter or leave may make that park and ride lot spot an environmental hotspot, right. Suddenly all these cold engines start up in the evening when people are returning from work, and now everybody wants to exit the park and ride lot and they have started up their engines. So that whole area becomes an environmental hotspot, and if there is a lot of residential buildings around it, people may object to it. So how do you plan environmentally for such situations? You have to have review plans. You have to monitor it often or periodically in order to prepare maybe some mitigation plans and so on and so forth. Okay, and then have obviously documented your implementation plans. So these are generic steps that needs to be followed in your in developing a system level park and ride facility. Then when we are talking about site level planning process, which site to pick for your park and ride facility becomes very important consideration, because the site, like I said, should not become an environmental hotspot such that it is inconveniencing the people who live around it. The cost of the land becomes an issue, because suddenly now you have a parking structure or a parking lot in the middle of a big residential area or a big commercial area, whatever it may be, that may play a role in picking which site you would develop your park and ride lot. The connectivity to the transit line is of course one criteria, right. You have to have the site well connected to the existing metro or BRT line. It cannot be such that there is 200-meter distance from your park and ride lot to the station. Then that extra 200-meter is something which becomes an inconvenience for the person who is parking at this lot, and he or she has to now walk, or if then you have to provide shelters for walking. Maybe during the rain it becomes a problem. So when you're designing, when you're picking a site, there are multiple considerations that you have to take into that you have to design for, and what we will be going through today is letting you develop this site analysis or this site picking process, if you may call it so. We will show you a mathematical way in which you can pick from alternate sites that you have. Again, if you want to have a checklist of all the processes, whether you have followed all the processes in the site planning process, you would definitely start with after you initiate the project, you develop a site level needs assessment and performance indicators. Again, you have to have certain performance indicators, performance measures, just like we had it in system levels. You have to have it now site specific level. Alternative site identification, always have alternatives against which you are ranking or rating this site maybe, for example. So, do not always put your money on one site. You can put your money once you have money on one site, once you have decided from an existing pool of alternatives. You evaluate all these alternatives, and then you come down to detailed concept level development and cost estimating for one site, which you have now thoroughly evaluated and said that this is the best possible site for my park and ride facility. After that comes your regular preliminary engineering and design and documentation, and final design and construction. Okay. So, these is a site level planning process which is pretty generic for any project that you want to take up, but in this case this is a park and ride facility, and we will take you through this process in a mathematical concept and allow you to understand how to pick a site for your park and ride facility. Again, you see that public involvement is at every step. So, do not ever leave the public out from your planning process, because that will eventually come back to bite you when these very public are the ones that will be using the system, and if you do not take them into confidence while building the system, then they may not use it once you have built it, and then all the money that you have put in the planning, design and construction process goes to waste, or you have to revisit your construction design, and then you put in a lot of money to change it, and it becomes a very expensive process. So, if you look at the entire ecosystem of a park and ride facility, this is what I was talking about in the first slide when I showed that there are maybe 3 different categories of park and ride lots. So, maybe here are your residential generators. So, here are your homes from where you would want to go to your CBD. This is here, and this is maybe the entire network, road network that is available to you. So, you could have your local, which is your neighborhood park and ride lots right here, where what could happen is that all of you take your individual cars and come to this, and from here everybody parks their own car and you all get into one person's car maybe, right. So, that is carpooling, right. So, you are not there is no transit that takes you from there. So, this is what is called an automobile park and ride lot, right. So, in automobile park and ride lot, what happens is if you are 5 friends who would want to ride together to your CBD, because all of your offices are very close to each other in the CBD. So, rather than that one friend go to each and everybody's house, what they usually do is, since this is a very neighborhood close by park and ride lot, each of them rides to this lot, and then maybe you take turns. So, on Monday you go with friend A's, go in friend A's car, and Tuesday you go in friend B's car, all the other cars are parked there, or whatever it is, you get dropped off, maybe you do not even park there, maybe a family member drops you off at that location because it is close enough to your home. So, that is kind of a neighborhood or a local park and ride lot. The other one is your regional park and ride lot. Now what you are getting to is, now you are coming out of your collector roads or your residential roads, and you are now on your primary arterial, right. Now, this primary arterial may be connected to different residential areas, right, and now that you have a situation where there are 5 people in a car, there may be other situations, there are 5 people in a car, all of them are coming to this regional park and ride lot, again parking their car, and now because this regional park and ride lot is well connected to the freeway, on which there may be your high speed bus service, or maybe on the median of that freeway is your metro service. So, now you can again park your car here and have access to your mass rapid transit. So, you see there could be 2 tiers of local park and ride lots and regional park and ride lots, which can then provide you access to your mass rapid transit line, which is generally along your freeways or highways, or even sometimes they are on your arterials, but in this case it is shown on your highways. So, this is the entire understanding of your travel from your residential areas to your CBD. Sometimes the other ones are you have your perimeter park and ride lots right around your CBD area, where you come, you are still driving, but you come here, and then from this point onwards you take your public transportation. But like the, if you see the peripheral, if the periphery park and ride lots, you would see that you would have already driven the majority portion of your trip. So, they are not that effective in reducing congestion or in reducing emissions. So, now we will quickly take you through a mathematical formulation of how to decide which site you want to locate your park and ride station at. The process that we are going to take you through is called the analytical hierarchy process. It is a multi-criteria decision making tool essentially that allows you to achieve your goal by solving for different criteria for different alternatives, right. So, you may have three different alternative sites for your park and ride lot, and each of those sites are characterized by different characteristics. Based on those solving for those characteristics or criteria, you can then achieve the goal of picking one site from these three alternatives. So, that is the entire idea of how analytical hierarchy process works. You ultimately your ultimate objective is to achieve the goal, the ultimate objective for the analysis. There can be only one goal for this analysis, that is the selection of a possible park and ride facility. So, that is your goal that you have to reach. Criteria, the basis on which the selection is made, there may be multiple criteria, hence this MCDM, multi criteria decision making tool. For example, the different criteria may be the transit type, the passenger volume, land use, etc. And the alternatives, of course, is the various locations that are available to you in order to set up this park and ride lot, right. So, since the siting of a location would be based on different criteria, right. It will not be only based on the land price, for example. It will not be only based on how close is it to the metro service. It will not be only based on what is the pricing that I can charge for parking. So, they will not be only based on individual single criteria, but they will be based on multiple criteria. So, a solution that solves these a solution that is reached by optimally solving for these multiple criteria will allow you to develop or pick a site with much confidence rather than just picking a site arbitrarily. So, for example, in step 1 of this AHP process, you have already identified your goals, criteria and alternatives. So, you know you have 3 sites from among which you have to choose, and there are these criteria that are common to some sites, these are specific to some sites. So, you have developed all your criteria, and then you know obviously the goal is to pick one site. What you do is you collect responses on pairwise comparison of criteria. So, on a scale, on a certain 5-point scale or a 7-point scale or a 10-point scale, you rate each of those criteria, right. So, think about this as a when you are trying to pick a phone, for example, when you are trying to buy a mobile phone, the different criteria in your head is how good is the camera, how good is the battery life, how good is the looks of the camera. So, for each of those you are giving a rating maybe, right. So, similarly think of these as rating for different criteria for picking a transit location. Now, who will give these ratings? Maybe some experts will give these ratings, maybe some users will give these ratings, right. There will be multiple stakeholders who are involved in this would give these ratings. Now, you would work with these ratings and then coming to a solution of picking a site. So, for example, one respondent may say that criteria 1 is highly significant as compared to criteria 2. So, whatever may be the criteria, he may give criteria 1 a higher rating, right. So, this one if he gives a rating of 1, meaning both criteria are equally important for this person. If he goes this way, criteria 1 is more important. If he goes this way, criteria 2 is more important. So, that is the entire step 2 for formulation of data collection, is to have responses collected from various stakeholders on where to provide these facilities. So, this is another example of a different respondent providing a different answer. So, he or she does not pick a number, but picks a number in between. So, you would have you will have to interpolate that understanding. Once you do that, then you construct what is called a decision matrix. So, this is the comparison of all the different criteria with respect to the goal. So, the goal is to pick a site. So, now you have different criterias. So, now you have to develop this decision matrix. So, when compared to criteria 1, criteria 5 is more important. So, for example, criteria 1 versus criteria 2 has scored 5. So, criteria 2 is more important when compared to criteria 1, whereas criteria 3 is less important when compared to criteria 1. So, this is how you develop a decision, what is called a decision matrix, from all the data that you have gathered, and you would see that obviously your diagonal would be 1 because you are not comparing criteria 1 against criteria 1. So, all of this would be 1. So, if all the diagonal is 1 and in this matrix you would have all the values on one side is the reciprocal of the value on the other side. So, that is how you develop the decision matrix for the criterias. So, this is a comparison of the criteria with respect to the goal. Similarly, what you do is you construct decision matrix for each of those criterias and comparing it with the alternatives. Now, you have to do a decision matrix for each criteria against the 3 alternative sites, right. Just as you have done it for the criterias against the goal, which is this, the criterias against the goal, you have to do for you have to develop a decision matrix using the same responses that you have got from all the stakeholders. Again, your diagonal is 1 and they are the inverse, the elements are inverse of each other across the diagonal. You develop it for each of these, how many ever criteria you have. In this case, you have 3 criteria. In the next step, what you do essentially is to normalize. Now, you have a matrix. How do you normalize the matrix? All you do is this is the matrix that you originally had for the criterias. You add up the columns and then you divide individual cells with the sum, right. You divide individual cells with the sum, and what you do is you develop a weighted average for the rows, right. Average for the rows, it is just the row average. So, you add these 3 and divide it by 3 because there are 3 of these, and you get these values. So, you normalize, first you develop a normalized matrix from the existing decision matrix, then you develop these this additional column of the row averages. You do similar calculations for all the alternatives with respect to the criteria. So, if this is a criteria with respect to the goals, you do similar things for each of these decision matrix and convert them into normalize them and then develop the row averages. Eventually, you will have this large of a matrix that will have each of the criteria weights as columns and each of the alternatives as rows, and all the weights that you would have developed from this step right here, right. All the weights that you have developed in here would fit right in here, and the additional column that you will have here is the total weighted sum. It is just the weighted sum. These weights are these. So, you just multiply that with whatever value is here and you sum across the rows, and the weighted sum will give you the composite weight. Now, this composite weight consists of weights of criteria against the goal and also the weights of alternatives against the criteria. So, this is the composite weight score, and this composite weight score will tell you which alternative, which A, B or C, which of the alternatives is the site that you want to pick, for example, in our case. So, the higher the value, the better is the site for our case. So, if we take an example of that and say that a group of experts and stakeholders are provided with a list of possible park and ride facility locations A, B and C. Again, we have 3 locations. The transport planner decided the following 6 criteria for assessment. So, instead of 3 criteria that we looked at here, now we say that the transport planner has looked at 6 criteria. The first criteria is transit type, the second is passenger volume, third is land use mix, fourth is NMT facilities, fifth is transit information, and the last one is fare structure. There are 6 criteria against which each of these sites have to be evaluated, and the responses have to be taken from the various stakeholders on this. Using AHP to develop the transport planner, select the facility, select the park and ride facility implementation. Also determine the most important criteria as judged by the group of experts and stakeholders for this selection. Following are the decision matrices. So, for simplicity, we have already developed the decision matrix for you. For example, this is the decision matrix for criteria against goal, right? All the criterias are in here, and then you have, since you have 6 different criteria. So, for each criteria against the alternatives, there is one decision matrix like this. So, this is the decision matrix for transit type, similarly for passenger volume, for land use mix, for NMT, for transit information and for fare structure. So, all of these have been given to you for simplicity's sake, but these have to be developed, remember, from the questionnaire survey that you have done with the experts and the stakeholders already. So, once you have developed these, you now know that your goal is to select the best park and ride location. Your criteria, you have 6 criteria, and your alternatives are 3 sites that you have with you. So, what do? You directly go into step 4A, 4B, where you have to determine the after normalizing, you have to determine the weights for each of the criteria against the goal. So, what you remember, what you all do is you have each of these. So, you sum it up. Once you sum it up, you divide this by this sum, you divide this by this sum, you divide this by this sum, you add up all that and divide it by 6, because you have 6 rows, 6 criteria here, and that will give you 0.304 for example, and similarly all of these numbers can be calculated. You do the same thing for all the matrices that are for the alternatives against for each of the criteria versus the alternatives. You similarly develop weightages for them. Once you have these individual weightages and once you have the weightages for the criteria, you will develop this massive matrix that I had shown you earlier. What this has is, it has all the criteria on the as columns, alternatives as rows, and this 0.304, where did we get this 0.304 from? Right from here, because that is the for the travel time criteria, that is the weighted average, normalized weighted average, if you may call that. So, you have 0.304 here, 0.148 comes from here, so on and so forth. And how does this come? For alternative A, for the criteria travel time, alternative A had weightage of 0.16, that is 0.16, alternative B had 0.59, that is 0.59, and alternative C has 0.25, this is 0.25. Similarly, you insert all of these from the individual matrices weightages that you have developed, and now you would see that you would get this value just as the weighted sum of each of these alternatives. So, weighted sum meaning you multiply each of these with each other and you sum it, right. If you multiply each other and sum this, you will get this. You multiply this with this with this and sum, you will get that. Multiply this with this with this, you sum and you get this. So, what this allows you to say is now you can rank them and you see that alternative A gets the highest composite weightage, right. Remember what this is? This is composite weight, right. So, you have now got alternative A has got the highest composite weight, B has the second highest composite weight, whereas C has the third. So, you pick this as your site or as your site for your park and ride lot. The question was also asked which was the most important criteria, and you can see that amongst the criteria 0.304 is the highest. So, travel time or transit type transit type is the most important criteria that goes into the selection of a park and ride lot. So, for example, maybe if your transit is a metro line versus your transit type is a BRT, then the location of a park and ride lot would differ in those two cases. So, that becomes a important the most important criteria from the point of view of all the stakeholders from whom you have surveyed. So, this is an example or a mathematical method, MCDM, multi-criteria decision making method, that will allow you to pick the site for your park and ride lot. I hope you have followed through with the example as well as the explanation that we have provided. Again, this is the AHP process. If anybody wants to read it, it's an old book, but it's a very easy to understand book that will allow you to understand how AHP process works. AHP is used in various other researches as well. So, it's a good technique to know about. So, in conclusion, what we have looked at in today's lecture is why is park and ride facility important, how what are the different types of park and ride facilities, how do you plan for it, system planning versus site level planning, and why location is an important factor in it, and how do you actually use a mathematical formulation which is an AHP to determine the location of a park and ride facility. Thank you very much for your attention.